We're back, still discussing laboratory and SI dry lab, and now I'd like to show you a couple of problems that are in your problem set, and one of them is actually part of your homework, so I'm kind of helping you a little bit with your homework and doing a problem for you. And I also would like to point out that here we're also having to add another wrinkle, if you will, to this whole discussion having to do with significant figures. So using significant figures properly in calculations is very important, and it proves to be somewhat challenging to students, so I'm going to show you some examples of that, and we're going to discuss it. I'd like to point out that in your lab manual, I did include, in my opinion, a very useful, very short, which is a big bonus here, discussion of significant figures. I'm talking about study aid 1. It starts on page 212 and then ends on page 213. So it's in the back of your lab manual, study aid 1, very concise, with examples. Usually when you read some of the explanations for sig figs, it can really put you to sleep, but this one I think is very good one, and I'd like to encourage you to use it anytime you need a reference for use of sig figs. And another thing that's useful in the back of your manual as you start working on your report on this, that I wanted to point out, and I referenced it in the assignment, that's Appendix A on page 187 in your lab manual. The reason why this one is good is because it's very exhaustive. It contains pretty much any conversion factor between English and metric system you could possibly want. And one of them that you will need to look up for one of the problems on here would be for pressure, right here towards the end of the page. One of the units is bars here, and so you can take this from bars to any other unit used for pressure, such as either torrs or inches of mercury or pascals or kilopascals. So B in your problem set in problem 5, I believe, stands for bars, and bars are right here. We will talk about it again when I discuss your assignment in a little bit more detail shortly. So now we're looking at problem number 3 from your problem set, and it's under part E of your report. And here you are asked to find volume in milliliters of 1 teaspoon. The problem provides some, but not all, necessary conversion factors. The problem itself tells you that 1 tablespoon is equal to 3 teaspoons, and that 1 tablespoon is equal to 0.5 fluid ounces. And so the plan here would be to go from teaspoons to tablespoons, then to fluid ounces, and then to milliliters. But then you realize that this last conversion between fluid ounces and milliliters is not provided, so we have to look it up. You can look it up either in table D12 that I showed you earlier, or in Appendix A. Both of those will tell you that 1 fluid ounce is equal to 29.57 milliliters. So that's something we actually had to look up. And in order to realize that, you need to look it up. If you write down the plan like I'm suggesting here, it basically shows how you would do it step by step, from teaspoons to tablespoons to fluid ounces, and then eventually to milliliters. You would realize that this one conversion factor was missing in the problem, and I think they probably did it deliberately, making you think about what kind of conversion factors you might need to complete the solution for this problem. So now, once we have all of our conversion factors provided and looked up, we're ready to set this up. Now, on the subject of significant figures, notice how I'm writing it here. I have 1.0 teaspoons. This here means that I will have to have 2 significant figures in my answer. I don't just have 1 teaspoon, I have 1.0 teaspoons. So this signifies the fact that my answer must be rounded off, or must contain 2 significant figures. So I'm starting with my first conversion factor. 1 tablespoon goes on top and 3 teaspoons goes on the bottom, so teaspoons can get canceled. And then my next one would be according to my plan from tablespoons to fluid ounces, which is what I'm doing in the next step here. 0.5 fluid ounces divided by 1 tablespoon, so tablespoon can now be canceled. And then my third one here would be conversion from fluid ounces to milliliters. Milliliters must be on top, so fluid ounces would be on the bottom and would cancel as a result. And once I do my math, I need to remember to round up my answer to 2 significant figures. So my final answer will be 4.9 milliliters with 2 significant figures in the end. So this is the first example of how you would do multi-step conversion between English and metric units. And then finally, we're going to take a look at problem number 4 in your problem set. And this problem consists of 2 parts, A and B, so we're going to do A and then B. Problem 4 talks about something familiar to everyone, which is a basketball. And first part of the problem deals with the pressure inside the basketball. So they want us to find pressure in ATMs inside the basketball, given that pressure inside the basketball is equal to 23.7 psi. Psi stands for pounds per square inch, and that's a common unit for pressure in the English system. So once again, we need to look up the conversion factor that would tell us the relationship between ATMs and pounds per square inch. And again, according to either table D12 or appendix A, 1 ATM is equal to 14.7 pounds per square inch. Setup here includes starting with 23.7 pounds per square inch times 1 ATM over 14.7 pounds per square inch. Why a pounds per square inch on the bottom? Well, because I have pounds per square inch here and I need to cancel them, so only ATMs remain. I would like to keep my answer to 3 sig figs, because I have 3 sig figs given here for my starting parameter. So when I do the math, I end up with 1.61 ATMs, and that should be 3 sig figs. So that's part A. And finally, part B. In part B, you're asked to find volume of the basketball in liters. The information provided is volume of a sphere. This is a formula from geometry, 4/3 pi r cubed. And the plan I'm suggesting, notice how always before I start doing things, I kind of try to think it through and come up with step-by-step plan for solving the problem. So first I'm going to find radius of my basketball in meters, and then I'm going to find volume of the basketball in meters cubed, and then third step will be to convert meters cubed to liters. This is not the only way to set up this problem, but in my opinion, it's the clearest and the easiest one. So, step 1, if a diameter of the basketball, which is given in the problem, is 10 inches, then radius, of course, is half of the diameter, or 5 inches. So we know that radius of the basketball is 5 inches, which we found from the diameter given in the problem. So we're taking 5 inches and we're converting it to meters cubed. I looked up the conversion factor. 1 meter equals 39.37 inches. And notice how I'm writing it 5.0 inches, because I would like to have 2 sig figs for my answer. And when I do the calculation and round off my answer to 2 sig figs, I'm going to get 0.13 meters. So now that I know my radius in meters, so I immediately switched from English to metric system in my very first step. I can now find volume of my basketball. Because I'm using radius in meters, and I have to cube it, my answer will come out in meters cubed. So 4/3 pi, which I'm using 3.14 and then 0.13 meters that I found my radius here, cubed. Doing the math and converting to scientific notation with proper number of sig figs gives me 9.2 times 10 to the negative third of meter cubed. So now I have my volume determined, but it's not in the units problem requesting, because problem requesting liters, and I have meters cubed here. So my last and third and final step of the problem is converting between meter cubes and liters. Again, looking up either in table D12 or appendix A under volume, you will find that 1 liter equals 1 times 10 to the negative third of meter cubed. In other words, 1 liter is 1,000th of a meter cubed. In other words, there's 1,000 liters in 1 meter cubed. All of this means this. 1 liter equals 1 times 10 to the negative third meter cubed. And so I'm taking my answer from over here, 0.0092 meters cubed, or 9.2 times 10 to the negative third meter cubed, times 1 liter goes on top, 1 times 10 to the negative third meter cubed goes on the bottom, because I want to cancel my meter cubed, and then I do the math and I get 9.2 liters with 2 sig figs. So my final answer to the problem would be 9.2 liters. Notice how I used my scientific notation, how I use significant figures, and how I set up the problem step by step. This again is something I strongly advise you to do for every problem you do. Now to your report and to your assignment. We're going to come over here real quick. So the questions I'm assigning for part E include 1, 2, 3, 3 we already did. That's the one about teaspoons and tablespoons. 5, 6, 8, 9. You must show all work on all units, similar to how I showed in my presentation, showing all unit cancellation and proper rounding with significant figures. Couple of important points. For question 5, there is a typo in the problem. It says barometric pressure of 0.92 MB. It has to be just B, not MB, so make sure you fix that. And this is how I will know who watched the video to the end, because if you don't, you're gonna get that wrong. So B here, not millibars, bars. B stands for bars. And if you look in appendix A on page 187, you will find how to get from bars, or in this case 0.920 bars, to other units. I believe it stands for inches of mercury and kilopascals probably. So that's an important point. So make sure all work is shown, use extra paper if necessary, and once you're done doing the problems, make sure it's legible. Take a picture with your phone, convert to PDF, and upload to Canvas for grading. I hope I addressed any possible questions you might have. Of course, myself and TAs will be available for questions and for help at announced times. Good luck.